Hello, my dear students. Good morning. How are you, my students? I hope all are doing great. Once again, welcome back to today's session. In last session, we have mainly studied about the ISO series, right? So, good morning, everyone. Jyotsna, good morning. Pratish, good morning. Good morning. Chandrasekhar Reddy, good morning. And some names I am not able to pronounce, but I am very happy to see you all of you guys attending the classes regularly and following the topics which we are discussing on daily basis. Good morning, Uma Maheshwara, good morning. Nagi Reddy, good morning. Good morning. Shall we start the class? Shall we start the class? Last class actually all of a sudden that was stopped. So I was in the middle of like isosters. In last class I have started about iso series. There we have discussed about isotopes, isobars, isotones, and I think I have given isoelectronic species also. Am I right? Happy morning. Happy morning. I am very happy to see you guys attending the classes and responding the classes. Good. We will start the class. Okay. Good morning, Janu. Okay. So, let me start by giving a small question and thereby we will move on to the next topic today. Today agenda is we will be continuing the rest ISO series and we will be talking about some important terms related to mass, atomic mass, molecular mass, relative atomic mass, gram molecular mass. These are most important definitions in chemistry. Okay, and my dear students, let me explain a few things about the topics which I am going to deal in the classes, because in chemistry the conceptual discussion will be there under organic chemistry and also even in physical chemistry. Okay, so I have started only basic terms and definitions, right? So there may not be connection of one topic with the other topic. So once from today onwards, after dealing the discussion about atomic masses, molecular masses, etc., we will connect these definitions to the mole concept. Once we enter into the mole concept, we will work many different types of questions. You will enjoy like anything. So before going to work on mole concept numericals and discussion, you need to have the basic understanding about few definitions and terms, right? Okay, good. Let me start with a small question. Okay, the question says in this way: mass number of question number 1, mass number of Zn, zinc, is 70. Mass number of zinc is given. You guys have to find out, then find the number of neutrons present in di-positive zinc, that is Zn plus 2. Okay, I have given the mass number and you guys have to calculate number of neutrons present in di-positive zinc. It means Zn plus 2. If you want the hint, I think many of you guys will be knowing about atomic number of zinc. Zinc atomic number is how much? Good. Yeah, some of you guys have given the answer already. Super. Very simple, basic question. So as we know that yesterday's class we have worked on representation of atom or nuclei. Here we have written the atomic number. Atomic number I have given it as 30 and mass number is given as 70. Okay, but I need the number of neutrons present in Zn plus 2. I hope atomic number remains as such and mass number also remains as such, since we have not disturbed the number of protons and neutrons. We have removed only electrons. Therefore, mass number yesterday we have discussed about mass number is the total number of nucleons. It means total number of protons and total number of neutrons, right? In counting the mass number, we have ignored the mass of electron, since the mass of electron is negligible in comparison to mass of proton or even mass of neutron. Good. So the answer would be, we have represented this mass number as A and atomic number as Z. Therefore, number of neutrons is equals to A minus Z. That is 70 minus yes. I hope you got the answer. Next, one more question. Question number 2. Atomic number of, next question is, let me write in this way. Number of protons in X2 plus is 15. Then find out the number of electrons present in X2 minus of the same element. This is in bracket. Yeah. Isosters we are going to start. No need to worry. We will start isosters. Very good. Very good. So in last class actually I have started with the isosters but we haven't completed. Now today we will be continuing on isosters. Okay. Now what is answer for this question? Okay. Now since atomic number was given as 15, atomic number is itself is number of protons. Therefore, number of protons or proton number is given. They are asking about number of electrons which are present in X2 minus. Okay. Since the element X atomic number is 15. Okay. Now X we are converting into X plus 2. X plus 2. It means number of protons in X is 15 itself, number of electrons also 15. But when we are moving towards X2 plus, its protons number is 15 only, no change in the proton number, but the electron count in X2 plus is 13. Okay. Now, moving ahead. I think this way of working also not needed, we can directly give the answer, right? So in X, number of protons are equals to 15 and number of electrons are equals to 15 in case of neutral. When you are converting X into X2 minus, protons number remains as such and electrons number is going to be increased by 2 units. Therefore, number of electrons becomes 17. Yes, right answer. Very nice. So, shall we move on to the next topic of ISO series? Have you got the answer? I hope you guys have got the answers. Next, isosters. Like it is seems to be like a synonym sisters, right? Okay, isosters. What are isosters? Okay, group of or species or compounds, ions or compounds, whatever it is. Ions are molecules or species with same number of atoms as well as same number of electrons. Underline these 2 points. Number of atoms must be same as well as number of electrons also should be same. Okay, fine. Now let's give an example of this category. The best known example is N2O and CO2. Let's check out whether these two compounds are isosters or not. Example B, KF and CaO. Let's check out whether the given pair of compounds comes under isosters or not. Let's check out. Here I am writing number of atoms. Here otherwise we will do one thing. Just give some space for this. Number of atoms. We have 2 plus 1, 3 atoms, and here also 3 atoms. Fine. Okay. Next, number of electrons. Number of electrons. As we know, nitrogen atomic number is, tell me atomic number of nitrogen. Atomic number of, I think you know about the elements from atomic number 1 up to atomic number 30. Atomic number 30. Thank you. Atomic number 1 up to atomic number 30. I think you must know, you need to learn the elements from 1 to 30. Okay. So here as I am giving, atomic number of nitrogen is 7 and 2 nitrogen atoms we have, and oxygen number of electrons are 8. Total number of electrons becomes now 14 plus 8, 22 electrons. And even here also carbon 6 electrons plus 2 times that of 8, again we are having 22 electrons. Good. Now KF, let's start to check out KF. Number of atoms. Number of atoms. Number of atoms. Check out 2 atoms I have, and even here also 2 atoms. And number of electrons. Check out the number of electrons. Potassium 19 plus fluorine 9. You are going to get 28 number of electrons. When it comes to here, calcium it is 20 and oxygen has 8 electrons. Together we have 28 number of electrons. Therefore, example A and B comes under isosters. Right? Is it clear? Is it clear, dear students? Is it clear, my dear students? Focus on the class. Up to 50 elements, up to 50, you know, very good. And Sudha, very nice. I think some of you guys even might be knowing about all 118 elements. I think many songs are there. When you are coming for offline classes, we'll ask us to sing the like chorus or like the song for all the elements. Fine. Next one is the last part of iso series is isodiaphers. So isodiaphers means here atoms are nuclei with same isotopic number. Isotopic number. Isotopic number itself is the difference between N and P, number of neutrons minus protons, or I can say same difference or same isotopic number I told, or other words same N minus P value. So atoms with same N minus P value are considered to be isodiaphers, or otherwise n in place of n I can write it as a minus p, sorry, a minus p I can write. In place of p you can also write z. So a minus 2p or a minus 2z. If any pair of atoms or group of atoms with same isotopic number, it means same value of n minus p or same value of a minus 2z. Let's cross check with an example. 5 boron 11, 6 carbon 13. Check out whether this pair of atoms comes under isodiaphers or not. Check out quickly. Now first I need to calculate n value. N value for boron is 11 minus 5, that is equals to 6. And for carbon atom 13 minus 6 equal to how much you are getting? 7. Right? Now let's calculate n minus p value. N minus p value for boron atom is 6 minus 5. Sorry, 6 minus 5. Yes, it's correct. That is equals to 1. And here 7 is number of neutrons, and 6 is the number of protons for carbon. Again we are getting value 1. Okay, is this clear? Isodiaphers, is it clear? Isodiaphers means atoms with same isotopic number or same n minus p value for both the atoms. Or I can also say a minus 2z value must be same. First step we have calculated n value. N value I got for boron as 6 and for carbon as 7. Then afterwards I have taken n minus p value, that is isotopic number. So 6 minus 5, that is equal to 1 for boron and again 1 for boron. Hence I can conclude that boron and carbon with given mass numbers and atomic numbers are coming under isodiaphers. With this we will close the iso series. I'll have some water. Okay, good. So we have completed isotopes, isobars, isotones, isoelectronic species, isosters and isodiaphers. Shall we move on to the next topic? I hope all these definitions and examples are clear for everyone. The very simple definitions and very simple examples I have given. And all the details and all the ISO series we will be studying once again under atomic structure chapter. Okay, so we are going to move for discussion about atomic mass and related definitions. Yes. Okay, good. Let's move on to the next topic. So in this topic we will be studying about basic definitions such as relative atomic mass, okay, B, atomic mass, C, gram atomic mass, D, average atomic mass. Majority of the students will have confusion about these definitions. If you are clear with these definitions, believe me students, you won't find any difficulties in mole concept topic. Okay, you must be clear with these definitions. You must be clear with these definitions. Okay, relative atomic mass, and I have mentioned only atomic mass. I have given even gram atomic mass also, and finally average atomic mass. Shall we start? Fine. Okay. Now look at, my dear students, in earlier days or in like old days or in ancient, I can't say ancient. Okay, they used to calculate the masses of atoms with reference to a standard element. Okay, just like if you are balancing something, we have to take the standard measurements on one side, the object or the things which we are going to quantify in other part of the balance. In the same manner, they used to measure the atomic masses in that way. For example, if I wanted to find out the atomic mass for, say, element X, this element mass was compared with a standard element. I hope you are following. Standard element. Standard element is taken on one part of the balance. The other part of the balance was taken in other part. Okay, the element was taken on one side of the balance, the standard element was taken on other side of the balance. Okay, now the standard elements they have taken as reference initially as hydrogen, which was taken by Dalton. Later on, they have taken oxygen as reference scale, and from 1961 onwards, they have taken carbon 12 isotope as standard element. I hope this point is clear. Okay, in order to find out okay, I'll answer all those points because we will be studying all these things. Fine. Okay, valency, all this stuff we will study. Don't worry. Each and every point, each and every definition, each and every concept, basic terms, basic definitions will be covering in bridge course. If you are following the bridge course schedule, believe me, some students, I suggest, I will encourage in this way. Some students, I hope some students were taken foundation courses. Some students might not have taken foundation courses. The students who has not taken the foundation courses, if you can follow the bridge course which we are delivering and which we are giving to you, if you can follow, so believe me, you can even study along with the people who have already taken the foundation courses. That means all the basic terms, definitions, concepts we are covering in the bridge course. Please follow properly and work on them, listen properly, and continuation, and try to attend the classes regularly. Fine. Now, so if you consider relative atomic mass, so first of all we will complete the relative atomic mass. Relative atomic mass, the term itself is explaining about relatively we are calculating. How we are calculating relatively? By taking one of the element as standard. With reference to this element, we are trying to measure the mass of the unknown element. Let's say, for example, let us consider the pen which I am using now. If I am taking this as a standard measurement or standard element, so I am taking the other part which I am going to measure the mass. Okay, so this is how many times heavier than standard element. If the unknown element is 2 times or 1 time heavier than the standard element, its atomic mass is 1. Relative atomic mass is 1. If it is 12 times heavier, its relative atomic mass is 12. If it is 16 times heavier, its relative atomic mass is 16. If it is 24 times heavier, its relative atomic mass is 24. In this way, they used to calculate the atomic masses. Okay, so I have to take the standard element on one side of the balance. The element which we are going to calculate the atomic mass need to be taken in other part of the balance. Then based on this, the unknown element is how many times heavier than the reference element, based on which we can measure the relative atomic mass. Okay. So who is going to calculate in this way? Earlier days they did not have the techniques. Now we have the technique which is very important, mass spectrometry. By using this experimental technique, you can find out the mass of any compound, any unknown compound we can measure. Okay, during olden days, they did not have such kind of privileges. That is the reason why with proper hard working, with proper initiation, with proper thinking, they were calculated these masses. So let's move on forward. Okay, relative atomic mass, if you want me to write the formula, I'll write the formula in this way. Relative atomic mass, RAM. Relative atomic mass. Okay, so here this part is I think half of the name of mine. Okay, fine. Relative atomic mass. Relative atomic mass is calculated in this way. Let's say mass of an atom of element upon mass of hydrogen atom. This is by reference to on hydrogen scale. This is the formula on hydrogen scale. This was outdated anyway. Next one I am going to give. Relative atomic mass is equals to mass of an atom, say X. Okay, let it be X, of an element upon mass of 1/16th part of oxygen atom. This is on oxygen scale. And or the last most important one, relative atomic mass. Okay, is equals to mass of an atom, say X, of an element upon mass of, I'll write with red color, mass of 1/12 of carbon 12 isotope. Mass of 1/12 part of 1/12. I need some more space. Mass of 1/12 part of carbon 12 isotope. Is this point clear? Is this point clear? Okay, here we are trying to measure the mass of a single atom. Whenever we are trying to measure the mass of single atom, we are actually calculating by comparing the unknown element with a reference standard element. Is this point clear? The reference standard elements we have taken as hydrogen, oxygen, and even carbon 12 also. Out of these three, from 1961 onwards, they are following carbon 12 isotope is the standard element to measure the mass of any atom. Is this point clear? And what might be the unit of relative atomic mass? What might be the unit of relative atomic mass? There is no unit, unfortunately, because we are comparing mass to mass. It is just a number. It is just the mass of unknown element is how many times heavier than the reference element. If it is 23 times heavier, I used to write the RAM as 23 only. If the If the unknown element is 16 times heavier than the reference element, then its REM would be 16 itself. Okay, I think this point is clear to everyone. Next, move on to the atomic mass. Shall we move on to the next definition? Is this point clear? Is this point clear? Is this point clear? Good. Next, atomic mass. Atomic mass. Then what is atomic mass? Atomic mass is mass of a single atom or an atom of element. Atomic mass is usually expressed in AMU. It means atomic mass units. Next point. It can also be referred as termed as Dalton, in recognition to the scientist Dalton, Avogadro, or it can also be referred as U. Okay, then I wanted to focus on this U. Now this is a present representation of atomic mass. Earlier they used to represent with atomic mass unit. Nowadays they are representing with atomic mass is represented with U. U refers unified mass. Is this point clear? Is this point clear? Now, can anyone tell me the value of 1 AMU? 1 AMU. 1 AMU itself is nothing but mass of total number of nucleons present in total number of nucleons present in 1/12 part of carbon 12 isotope. It means nothing but mass of a nucleon. Then if I refer 1 AMU, this is nothing but mass of a nucleon. What is its value? 1 AMU is equals to 1 AMU value is equals to, can anyone? 1.66 into 10 raised to the power minus 24 grams. I hope these points are clear. Very nice, very good. Nice answer. Name I am not able to pronounce, but it's good. Okay. So with this, I wanted to summarize about atomic mass. Dear students, atomic mass, as I mentioned, mass of a single atom, mass of an atom of an element. Earlier we were calculated the mass of an element with reference to standard element. Now I am trying to define in this manner. It is expressed in AMU and it can also be termed as Dalton or Avogadro or U. Now present representation of atomic mass is unified mass. It is represented with U. Now coming to the point of AMU. 1 AMU is nothing but mass of total number of nucleons present in 1/12 part of C12 isotope. It is nothing but, if you can say, mass of one nucleon only. Mass of one nucleon. Fine. Let's move on to the next point. Gram atomic mass. So it can be represented in short as GAM. Define gram atomic mass. Gram atomic mass is the mass of or atomic mass represented in grams. Atomic mass represented in grams. The second definition is mass of 1 mole of atoms in grams. Okay. Now here I referred a term 1 mole. It represents how much number? I think you know very well, very well. Here I am going to write the third definition or third point. Mass of or mass corresponding to 6.022 into 10 raised to the power 23 atoms in grams. So those many atoms mass, if you can measure, such mass is considered to be gram atomic mass. Some students may also write 6.023. Don't worry, no need to worry. You can write anything. Or I suggest 6 into 10 power 23 is best version. Yeah, mole concept is there. Lavanya, mole concept is immediately after giving the definition about all the terms which I have mentioned here. Right? After having idea about the relative atomic mass, gram atomic mass and mole definition, and followed by molecular mass, gram molecular mass. So after giving all these definitions, we will go for mole concept topic. Fine. Now, so is this point clear? What is gram atomic mass? As I mentioned already, many students will have confusions on definitions related to atomic mass, gram atomic mass, relative atomic mass. I wanted to introduce one more atomic mass, that is average atomic mass. Don't confuse with these terms. So you should have a clear-cut idea about, crystal clear idea about these definitions. As I mentioned, why we have called this as relative atomic mass, why we have called it as relative atomic mass. Since the atomic mass was calculated in reference to standard element, that is why we have named it as relative atomic mass. For relative atomic mass, we don't attach with any units. Now coming to the atomic mass. Atomic mass was actually the mass of a single atom, which was usually expressed in AMU, or a present form is U. Now the third definition which I have given is gram atomic mass. Gram atomic mass is the mass of 1 mole of atoms in grams, or mass of these many atoms. These many atoms is collectively referred as 1 mole. 1 mole. Okay. This number is called as Avogadro's number. Avogadro's number. And its value, as I mentioned already, it is represented with Na. Not sodium. N small a, you are not supposed to represent with Na. It is not the representation of Avogadro's number. It is actually sodium. Some people used to represent the Avogadro number as N small a. It is not correct. You are supposed to represent with Na. Okay. Fine. Let's move on to the next definition. Next definition. Average atomic mass. Fourth definition is average atomic mass. Why we are referring here average atomic mass? Since in order to find out the atomic mass, you have to collectively consider all the isotopes which are related to a particular element. Let me give the formula first. Average atomic mass, average atomic mass. I think you can give the answer or you can give the formula. That is x1 into m1 plus x2 into m2 plus x3 m3 and so on by x1 plus x2 plus x3, where x1 comma x2 comma x3 and so on are called as percentage abundance of isotopes respectively. Where m1, m2, m3 etc. m1 comma m2 comma m3 are the mass numbers of the corresponding isotopes. Fine. Okay. Now let's take an illustration example. Calculate why we are referring here average atomic mass, as we know that an element is composed of many isotopes. Each isotope has different mass number. In order to find out the average atomic mass, we have to consider all the isotopes and their percentage abundance. You may have doubt about percentage abundance. Percentage abundance means the percentage availability of a given isotope in nature. Percentage availability. For example, question, I will give one question. We will try to solve the question. A chlorine sample has two isotopes, namely chlorine 35 and chlorine 37, with percentage abundances (75 and 25 respectively. Then find out the average atomic mass of chlorine. Yeah, you will get the answer. Definitely, I think you might have worked already such kind of example. It is a very simple example, very simple, very simple. Yeah, can also fractional abundance, percentage abundance can also called as whatever it is. Abundance itself means how much amount is available in the nature. If you take a sample of hydrogen, hydrogen has composed of protium, deuterium and tritium. Protium is available in how much amount, how much percentage. I have given the example as chlorine. Chlorine example, two isotopes we have, chlorine 35 and chlorine 37, right? So I think you have given the answer also. Average atomic mass of chlorine, average atomic mass is equals to, so the element with 35 has percentage abundance as 75, therefore 35 into 75 plus 37 into 25, I can manage to write Okay, because this hand is paining. Fine. Now here total percentage of abundance of all the isotopes is 75 plus 25. Altogether I have 100. So if we can simplify this calculation, you will get the value as approximately 35.5 percentage. That is the reason why we have called the atomic mass of chlorine as average atomic mass. Okay, my dear students, with this I wanted to close. In today's session, we have mainly discussed about isosters, isodiaphers, and I have covered few definitions related to atomic mass, relative atomic mass, gram atomic mass, and also average atomic mass. My dear students, we will be continuing the same definitions in tomorrow's class also. And from tomorrow onwards, we are going to start a mole concept topic, which is really very important in chemistry for both first year and second year. So please try to learn the concepts which I have given and definitions which I have given, and try to go through the points which we have discussed in the class. And please don't miss next class, because next class is going to be very important and interesting class. So with this I wanted to close. Thank you so much, and I love you so much. That's all for today's class. Thank you.